Hello everyone, welcome to physics class standard 8 chapter 5 light energy. In this chapter we will study about refraction, curved mirrors, image formation by curved mirrors and dispersion of light. First of all we discuss about refraction. So before discussing about refraction, let us know how does the light travel. You know that light travels in a straight line in any medium. When light travels in any medium, it always travels in a straight line. But when light travels from one medium to another medium, it changes its path. So now let us define refraction. Refraction is defined as the phenomenon of bending of light when it passes from one medium to another medium of different density. Light travels at different speed in different media. In different medium, the speed of light is different, and this is why refraction occurs. The speed of light differs in different media due to the difference in the densities of the media. So the question would definitely come to the mind that why does the light travel at different speed in different media? Because the speed of light, because the density of different media are different. This is why speed of light differs in different media. So what is refraction? Refraction is defined as the phenomenon of bending of light when light passes from one medium to another medium of different density. Now let us look at the ray diagram given above. The ray of light AO, this is the ray of light AO which is traveling from air into water. This surface between two media. This surface which separates the two media, one is air medium and another one is water medium. So this surface separating two media is known as the interface or boundary. Here XY is the boundary. Look at the figure carefully. XY is the interface of air and water media, or XY is the boundary of two media. The point where the ray hits the water surface is called the point of incidence. Here O is the point of incidence and AO is the incident ray. The ray of light which hits the water surface is called the incident ray. A perpendicular line drawn to the point of incidence at the interface is called the perpendicular. So MO is the perpendicular. MO is called the normal. The angle which the angle made by incident ray and incident ray AO and perpendicular MO is called the angle of incidence, and it is denoted by I. When the light enters the water medium, the ray of light bends its path from its original path. It means that the ray of light is refracted. The angle and here the light which is in the water medium, the path of light or the ray of light which is in the water medium OB is called the refracted ray, and the angle between normal ON and refracted ray OB is called the angle of refraction. Now, laws of refraction. The incident ray, refracted ray, and the normal drawn at the point of incidence all lie in the same plane. The ratio of sine of angle of incidence to the sine of angle of refraction is always a constant, and this constant is called the refractive index for this pair of medium, and this law is also known as the Snell's law. So sine I by sine r is equal to constant is equal to mu. Mu is the refractive index. Therefore sine I is equal to mu sine r. Here mu is the refractive index of medium 2 with respect to medium 1 when light travels from medium 1 to medium 2. Now let us define refractive index. Refractive index of medium 2 with respect to medium 1 is defined as the speed of light. It is defined as the ratio of speed of light in medium 1 with the speed of light in medium 2. It is denoted by mu 2 1. Refractive index is a property of medium. So mu 2 1, that is refractive index of medium 2 with respect to medium 1, is equal to speed of light in medium 1 by speed of light in medium 2. If a ray of light moves from air medium to water medium, then air is the first medium and water is the second medium. You see here in this figure, here the ray of light travels from air medium to water medium. So air is the medium 1 and water is the medium 2. So in this case, refractive index would be mu refractive index of water is equal to speed of light in air by speed of light in water. You know that speed of light in air is 3 into 10 to the power 8 meter per second. 3 into 10 to the power 8 meter per second by speed of light in water is 2.25 into 10 to the power 8 meter per second, which is equal to 1.33. Refractive index is a unitless constant for two given media. It just gives an idea by how much amount the speed of light is altered when it enters from one medium to another medium. If a medium has a lower refractive index, the speed of light would be high, whereas the speed of light would be low in a medium with higher refractive index. Remember, it is a very important point. The speed of light is high in a medium with lower refractive index, and the speed of light is lower when it travels in a medium with higher refractive index. These are the refractive index of some transparent substances. Refractive index of water is 1. So the speed of light in air is 3 into 10 to the power 8 meter per second. Refractive index of water is 1.33. So its so speed of light in this medium is 2.25 into 10 to the power 8 meter per second. In a glass, refractive index is 1.5. So the speed of light in this medium is 2 into 10 to the power 8 meter per second. In diamond, its refractive index is 2.4. So speed of light in this medium is 1.25 into 10 to the power 8. Now you see some special properties of refraction of light. When light travels from a optically rarer medium to a optically denser medium, it bends towards the normal drawn at the point of incidence. In this case, angle of refraction is always smaller than the angle of incidence. You see in this figure, in figure A ray of light travels from air medium to water medium. Air is the rarer medium than the water because refractive index of air is smaller than the refractive index of water. This is why air is the rarer medium and water is the denser medium. So when light travels from optically rarer medium to optically denser medium, it bends towards the normal, and in this case angle of refraction is always smaller than the angle of incidence. Angle of incidence is theta 1 and angle of refraction is theta 2. You see in this figure it is very clear that theta 2 is smaller than the theta 1. In figure B, the rays of light travels from water medium to air medium. Refractive index of water is more than the refractive index of air. This is why water is the optically denser medium and air is the optically rarer medium. When a ray of light travels from optically denser medium to optically rarer medium, it bends away from the normal. And in this case, angle of refraction theta 2 is always greater than the angle of incidence theta 1. Third point, when light is incident normally on the refracting surface, it travels straight. You see, the ray of light strikes the interface normally, so it travels straight. In this case, the ray does not change its path. Both the angle of refraction and angle of incidence are equal to 0 degree. In this case, angle of incidence and angle of refraction is 0 degree. When ray incident along normal, it goes undeviated. It does not changes its path when it enters to another medium. Now some numerical problems based on refraction. A ray of light in incident at angle of 40 degree on the ethanol having a refractive index of 1.36, at what angle would be it refracted? So let us give an angle of incidence I is equal to 40 degree, that is sin I is equal to 40 degree. Refractive index mu is equal to 1.36. Now angle of refraction R is equal to how much? So from Snell's law you know that mu is equal to sin I by sin R. So sin R is equal to sin I by mu. So the sin 40 degree is equal to 0.643 by 1.36, that is 0.50 or 1 by 2. Sin R is equal to 1 by 2. So which value of sin is 1 by 2? 30 degree. So R is equal to 30 degree. That is R is equal to 30 degree. Calculate the speed of light in a medium whose refractive index is 1.52. The speed of light in vacuum is, we know that, 3 into 10 to the power 8 meter per second. So refractive index mu is equal to 1.52. So mu is equal to speed of light in air by speed of light in other medium. So mu is equal to 1.52 is equal to 3 into 10 to the power 8 meter per second by speed of light in other medium. Therefore, speed of light in other medium is equal to 3 into 10 to the power 8 meter per second by 1.52, which is equal to 1.97 meter per second. This medium is made up of glass. Now let us see refraction through a glass slab. A rectangular glass slab is a piece of glass bounded by two parallel glass and air boundaries. When a light rays enters a glass slab, it suffers refraction twice at its two boundaries, separating the air and glass and air. So let us see the concept of refraction with the help of some example. Emergent ray, the ray that finally comes out of the glass slab, is called as the emergent ray here. BC is the emergent ray. AO, this PQRS is a glass slab, rectangular glass slab, and MO or dash. MO is the incident normal to the interface 1, and NB is the normal to the interface 2, that is SR, interface SR. Here AO is the incident ray in interface PQ interface. AO is the light ray traveling from air to glass, so AO is the incident ray and OB is the refracted ray for interface PQ. Now in second interface, or in interface AR, that is from air, glass to air, OB is the incident ray and BC is the refracted ray or emergent ray. The refracted ray OB travels through the glass slab till it encounters the another boundary SR. The ray suffers refraction and deviates away from the normal. In the first case, from air to glass, the refracted ray bends towards the normal. In second case, in SR interface, when the light ray travels from glass to air, the ray of light moves away from the normal. The ray that emerges out of the glass slab is known as the emergent ray. If the ray is produced backward, it will be parallel to the incident ray. The distance, so now the angle that emergent ray makes with the normal is same as that incident angle. Thus, emergent ray is parallel to the incident ray but laterally displaced by some distance. The perpendicular distance between the incident ray and the emergent ray is known as lateral displacement. This is the lateral displacement. This distance is the lateral displacement. More the distance the refracted ray travels into the glass slab, more it is laterally displaced. Example of refraction. The two common examples are, one is formation of mirage and advanced sunrise and delayed sunset. Mirage formation. A traveler has lost his way in the desert. Suddenly the traveler sees a simmering puddle of water on the horizon, but as soon as the traveler reaches the puddle of water, it disappears. You must have read or heard about this story before. In reality, the puddle of water is a mirage, an optical illusion. A mirage is an optical illusion. Mirage formation is an example of refraction of light. And the desert, the ground is hot in the daytime, so the hot ground warms a layer of air just above the ground, while the air in the sky is cool. When the light moves through the cold air and enters into the layer of hot air, it gets bent or refracted. It refracts and forms nearly a U-shape. Our brain does not see the image through bent light from the sky. Instead our brain thinks the light must have come from something on the ground, and thus a puddle of water is visible to a traveler in the desert. This is the formation of mirage. Advanced sunrise and delayed sunset. We actually see the sunrise about 2 minutes before the sun is actually at that position, and the sun that we see actually of a sun we see is actually of a sun that has in reality already set. You see, the rays from the sun travels into space and then enter the atmosphere. That is, they travel from a rarer medium to a denser medium. When the sun is about to rise and is present just below the horizon. Now you see this picture, this is the horizon. Now the sun is just below the horizon. The rays from the sun travels in the space and gets bent as soon as they enter the atmosphere. On the earth, here is the observer. On the earth, the observer follows a straight path. You see, this is the observer follows a straight path of rays entering the eyes and actually sees the sun. He actually sees the sun here, slightly above its actual position. It is the rising sun, but it is its apparent sun or actual position. And as a result, he sees the sun about 2 minutes earlier than the actual sunrise. Similarly, in case of sunset, the apparent position of the sun is visible to us and not the actual position due to the bending of light rays. So this is all about refraction of light. In the next video lecture, we discuss about the curved mirrors and the images spawned by curved mirror. Thank you.